So we're back with another chapter for class 6 chemistry, and the name of the chapter is atomic structure. In this chapter we need to re-study what is atoms and molecules. So I don't want to get into the details about atoms and molecules because we have already discussed what atoms are and what molecules are, right? But out here we're going to discuss about how atoms can be broken down. Okay, atoms can be broken down into three different smaller particles, okay, and they are called electrons, protons, and neutrons. Okay, so atoms can be further divided into electrons, protons, and neutrons. Okay, electrons are negatively charged, protons are positively charged, and neutrons have no charge. Okay, electrons are negatively charged, protons are positively charged, and neutrons have no charge. So atoms can be further divided into electrons, protons, and neutrons. Okay, so this is how an atom looks like. In the center you'll have, in the center out here in the blue square, that's the nucleus. Out there we'll have protons and neutrons. Electrons will be going around this is where your electrons will be. Okay? This is where your electrons are. So out here, your blue circle is your nucleus where neutrons and protons exist, and electrons exist in this concentric circles around the nucleus. Electrons, they revolve around the neutron. Electrons, they revolve around the nucleus. Okay, these are your electrons are written as this or this. Okay, negative E or E negative, up to you, whatever you would prefer. Okay, this is how I'll be writing electrons from now on. Now let's move on to we talked about the structure of the atoms. We talked about atoms can be broken down into three smaller particles called electrons, which are negatively charged, protons, which are positively charged, and neutrons, which are neutral. They have no charge. They are not positive, they are not negative, they are neutral. Okay? So next we move on to atomic number. And not just an atomic number, let's look at how to read a periodic table. Okay? To read a periodic table, we go from number 1 to 2, atomic number 1, that is hydrogen, atomic number 2, that is helium, 3, lithium, 4, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. You guys need to remember 20 elements, that is up to calcium. It starts from hydrogen to helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Okay? So these are the 20 elements that you need to remember. You need to remember the atomic number and their electronic configuration, which we will get into. Okay? Now, how do you read a periodic table? First thing is, you have got your non-metals, you've got your metalloids, you've got your halogens, and then you've got your noble gases. Okay? These are your gases which do not react with other elements. These are elements which do not react with other elements. Okay? Why? Again, we'll get into that when we study electronic configuration. Okay? Now let's look at iron. This right here, this Fe is its symbol. Okay? That is your symbol of iron. Fe. We don't write I-R-O-N for iron, we write Fe. Okay? This 26 on the top is the atomic number. Atomic number is always on the top. And then you'll have another value which will be below. It will be the atomic mass. Okay? Atomic size is not given there. In some periodic table, atomic mass is also given. Atomic size is also given there. Its electronic configuration is also given there. Its charge is also given there. Its valency is also given there. But mostly, what you find is the symbol, the atomic number, and the atomic mass. We will not get into atomic mass in class 7, but we'll get into atomic number right now. So what does the atomic number tell us? Okay, like out here, from there we got to know that hydrogen has an atomic number of 1 and helium has an atomic number of 2. Okay? And boron has an atomic number of 5. So what does it mean? It means that hydrogen has 1 electron, it has got 1 proton, and it has 0 neutrons. Okay, it has got 1 electron, 1 proton, and 0 neutrons. Why? Because mass of hydrogen is 1. If it is 2, then these two will combine. The atomic number gives us the number of electrons, and number of electrons is always equal to number of protons. Okay? Now, in an element, the number of electrons and number of protons are equal. Okay? So, we don't need to know about neutron right now. We need to know that neutron is there. Neutron gives us the mass. It does not give us the charge, but it gives us the mass. But we'll study in detail about that in higher classes. Okay? So if you were to write its hydrogen's electronic configuration would be 1 electron up there and 1 proton in the nucleus. Okay? I'm using green for proton and red for electron. Proton is green, electron is red. Okay? So it has hydrogen has one electron and one proton. Okay. Now, if there were two electrons, it would end up being helium. It would end up being helium. Okay. So helium has two electrons, and it has, since it has two electrons, it will have two protons. Okay. So helium has two protons and two electrons. And again, we will not get into the neutrons. Why? Because we'll study that in higher classes. Next, boron. Boron has 5. Okay, so it means it has got 5 protons in the nucleus. So you have 1, 2, 3, 4, 5. Okay, so it has got 5 protons in the nucleus. How many electrons does it have? Again, 5. And where are they? 1 and 2. And that's the maximum number of electrons, the first shell. Okay, each of these are called shell, and first shell can only have 2. Okay, 2 electrons. Number of electrons that can be present in first shell is going to be just 2. So how many left? 3. So what do we do? 1, 2, 3. Okay. So boron's electronic configuration will be 2, 3. That is how we write the electronic configuration. For helium, it would be 2. Okay. Now, if we had fluorine, which has 9 electrons, okay, so the fluorine's atomic number is 9. So it has got 9 electrons and 9 protons. So this time I'm not going to put the protons there in the center, because protons are there, 9 protons are there in the nucleus, and we know about it. There's no point writing it. Okay? So we just move on to the electrons. How many electrons are going to be there? First one is, first shell will have just 2. 1, 2. Okay? So how many left? 7 left. So what are we going to do? We put 7 out there. And lastly, 3, 4, 5, 6, 7, 8 and 9. Okay, so fluorine is the electronic configuration of fluorine is going to be 2, 7. Okay, so that is how we break down. Each shell has their own name. This first shell is, we name it as L, then M, then the next shell would be N, O, P, Q, R, and so on. Okay, if you had more shells, the shells would be M, N, O, P, Q, R, blah, 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 blah. So we discussed that first shell, that is the L, has the capacity for just 2 electrons. How much is the capacity of the second shell? It is 8. Third shell, again 8. Okay. From the second shell onward, from N onwards, all of the shells will contain 8 electrons. So far, I hope you are there with me. Okay, if there is any question regarding any of these, please contact me. And let's move on to next thing. Like I said before, I'm not going to talk about atoms and molecules because we have already studied that and we already know that. So I'm going to skip another part of this chapter which we have studied in class 6 is atomicity. Okay, basically how many atoms of an element come together to make one molecule of that element. Okay, like for example, monoatomicity like helium and neon and all of the noble gases where just have one atom. Diatomicity like oxygen and hydrogen where there are two atoms that come together. Okay, triatomicity like ozone where there are 3 atoms of molecule or 3 atoms of oxygen that come and make one molecule of ozone. Polyatomicity like 4 atoms of phosphorus which come together to make one molecule of phosphorus. So I'm not going to go into that. But what I'm going to talk about is why do these atoms come together? They come together because they need to be stable. Okay? Every element out there they want to be stable. They can only be stable if their electronic configuration is 2, 8, 8, so on. If each shell is full, okay, they do this by either taking the electron, okay, or by giving the electron. They either give the electron or either take the electron. And how does it work? Imagine there is an element whose configuration is 2, 8, 1. So it has one extra element. And this one is stopping it from being stable. So what it does is it gives this one. Okay, it gives this one electron. When it gives this one electron, it becomes 2, 8. Since it is giving the electron, if you give the electron, then you become positive. If you give the electron, then you become positive. So it becomes, electronic configuration becomes 2, then plus it becomes positively charged. Okay, it becomes positively charged. But if its configuration was 2, 7, again one electron stopping it from being stable. So what it does, it takes an electron. It takes one electron, it becomes 2, 8 and it becomes negatively charged. Okay, so if an atom gives the electron away, then it becomes positively charged. If it takes the electron, then it becomes negatively charged. Remember once again, to be stable, atoms, they either give the electron or they either take the electron. To take the electron, if they take the electron, they become negatively charged. If they give the electron, then they become positively charged. Okay, so what are the elements which give the electron? Elements which has 7, 6, 5, sometimes even 4. Okay, they take the electrons. Electrons which has 4, 3, 3, 2 and 1 they give. So elements which has 4, 3, 2, 1 elements, elements which has 1, 2, 3 and 4 electrons in the outer shell, they give the electron. They just say, take it. I want to be stable. Okay? They can be stable by just being very altruistic and giving the electrons. But elements which has 7, 6, 5 and 4, okay, number of electrons in the outer shell, what they do is they take and they become stable. All of these will be negatively charged. All of these will be positively charged. That is, after giving the electron, they will be positively charged. After taking the electron, they will be negatively charged. Okay? Sometimes you will see a symbol with a negative charge and the number. Okay? It means that that's the amount of electron it can give or take. We'll study about that. Okay, so we discussed that if they take the electron, they become negatively charged. If they give the electron, they become positively charged. You see, 4 is common on both these lists. Why? Because elements which has 4 electrons on the outer shell can either give or either take. It's up to them. They can decide. Okay? They sometimes give, sometimes they don't. Sometimes they take. Okay? So, that is that. Next is, now let's look at chlorine and sodium. Sodium has 11 electrons. Okay? And chlorine has 17 electrons. Okay? And we have discussed that if they have 1 electron, then what they do? They give. Okay? So what it does is it gives an electron, and this guy takes an electron. This becomes 2, 8, 8 and becomes negatively charged. Becomes negatively charged. This becomes 2 and 8 and it becomes positively charged. Okay? Sodium has 1, so it gives. Chlorine has 7, so it takes 1. Sodium gives 1, chlorine takes 1. So when we form sodium chloride, this 1 electron goes here and this becomes stable. Okay? It becomes stable by being 2, 8, 8 and this becomes stable by being 2, 8 and giving the electron. Okay? That's that. The number of electron an element can give or take to be stable is called its valency. Okay, valency is basically the number of electrons an element can give or take. Okay, if it is -1, then it means that -1 means it takes the electron. Like we discussed before, if it takes, then it will be negatively charged. If it gives, then it will be positively charged. If an element gives 1 electron, then it will be positively charged. So valency will be +1. If element takes 1 electron, it will be negatively charged and its valency will be -1. Okay, valency again is the number of electrons you give or take to be stable. Okay, and if you give 1 electron, you'll be positively charged, so your valency will be +1. If you give 2 electrons, then again you will be positively charged, right? Because you're giving, and your valency will be +2. If you're giving 3 electrons, then the valency will be +3. If you're taking 1 electron, your valency will be -1. If you're taking 2 electrons, then your valency will be -2. If you're taking 3 electrons, then your valency will be -3. Okay, so that's all for valency. Now we move on to something called radicals. What are radicals? Radicals are a group of atoms of different elements which acts as a single element. Okay, like for example, hydroxyl ion OH, which is negatively charged, and NH4, which is NH4, which is your ammonium. Okay, they act as a single element, and their valencies are 1. A negative radical is known as anion, and the positive radical is known as cation. Okay, there is a table in your book on page number 71 where there are different radicals. You can go through it, you can go through the valencies. There are different tables in your book where you can understand valencies and other things. And for this chapter, this is all that you need to know. Again, I repeat, if there is anything that you don't understand, contact me. Okay? If there is any question, please feel free to contact me and ask that question and clear your doubt. Till then, thank you for watching the video.